In this lesson, we're going to look at two examples of radical functions. And the first one is a square root function. We will focus on how to find the domain, the range, and then later on we're going to fill up a similar graphic organizer so we can demonstrate how to graph it. So the parent square root function is given by f of x is equal to square root of x. Now sometimes you may also write it as y is equal to square root of x. Now, how do you find the domain of a parent square root function? We know that the square root is only defined when the radicand or the quantity inside the square root is positive. So that means we're going to copy the expression inside the radical symbol and make it greater than or equal to 0. Now for the range, since x is greater than or equal to 0, if we look at the graph here, then the range will also start from 0 and all the y values here are positive. So the range is y greater than or equal to 0. Now if you remember when we did quadratics, we created tables of values. So how will you make a table of values for a square root function? So when you make a table of values, you have to be wise in choosing the value of your x. So this is x, and this is the square root of x. So since 0 is part of the domain, we can start with that. And the square root of 0 is 0, right? Definitely you can pick a number that's less than 0. So can we pick 1? Yes, definitely. So square root of 1 is 1. Can we pick 2? Yes, for sure. But the square root of 2, since 2 is not the perfect square, will be a decimal. So if we're not using any technology or calculator, then it's wise to choose numbers that are perfect square. So I'll skip 2, I'll skip 3, and then when I get to 4, oh, 4 is a perfect square. So what's the square root of 4? The answer is 2. There you go. So if you remember, when we're doing quadratic functions, we use from -2 to +2. I think those 5 points, were enough to come up with a very good shape of the graph. Now for graphing square root functions, it's up to you how many perfect squares you guys are going to use. So let's say, for example, this is 4, its y value is 2. But I think 3 points can give you the shape already. The graph will be, rising to the right, so it's continuous. It's increasing from, from 0 to positive infinity. So it's up to you how many perfect square numbers you're going to use. So this is 9, and the square root of 9 is 3. There you go. So I hope that gives you an idea of what a square root function is. So if you recall, when we're talking about the domain, we're referring to the possible values of x. There you go. And since we're talking about square root functions, just like what I mentioned earlier, the radicand must be positive. So it has to be greater than or equal to 0. So the radicand is, any expression that's under the radical sign. So if we're going to solve the first one, how are we going to find the domain of h of x? We are going to copy not just the negative x, but the entire expression that's under the square root symbol. So let's copy negative x plus 1. Now we said that the radicand must be non-negative. It has to remain greater than or equal to 0. So when is this greater than or equal to 0? Use what you learned about inequalities to get the value of x by itself. So that means we're going to move the 1 over. So you have negative x is greater than or equal to 0, take away 1 will become negative 1. So from positive, change to negative. Now, when you divide both sides of an inequality by a negative number, remember you have to flip the inequality symbol. So this will become x is less than or equal to negative over negative is now positive 1. So that means the domain of the first square root function, or h of x is greater or less than or equal to 1. In interval notation, you may also write that as negative infinity to positive 1, close interval, so use a bracket. For the next example, there's the positive 3 added outside the radical symbol. So do you have to copy that to find the domain? No. You just have to copy the expression inside the radical sign. So x is greater than 0. But since, x is already by itself, and you don't have to do any more calculation. Now, what if there's a number or a coefficient before the x, and there's a number outside the radical sign? So what are you going to copy? So you are only going to copy this. So 2x is greater than or equal to 0. You have to divide both sides by 2 to get the x by itself. So x is greater than or equal to 0. So for the domain, you can write this as from 0 to positive infinity. And this one is the same, from 0 to positive infinity. Alright, so I hope these examples helped you understand how to find the domain of square root functions.